Okay, ladies and gentlemen, this is Unit 8, Notes 1, Simplifying Radical Expressions for Algebra B. So, simply enough, what you need to be able to do is simplify a radical expression. Remember, this is the radical sign. And so that's kind of all we're dealing with. So, when we say simplify, we mean start with this. Start with prime factorization. Prime factorization means break it down to just prime numbers. Just prime numbers means only numbers that can be split or that can be divided by 1 and itself. 1 and itself meaning the number. So if I go 63, most kids are going to see that and go, hey, 9 and 7. And that's fine, but then you have to realize that 9 is not a prime number. I've got to split that again into 3 and 3. So prime factorization will be 3 times 3 times 7. 98, if you're clever, you'll go 49 and 2, because that's the one that kind of jumps out the easiest. But then recognize 49 goes 7 and 7. So prime factorization will be 7 times 7 times 2. 180 can be done a whole bunch of different ways. The one that kind of jumps out at me would be 18 and 10. And then realize I can split those again. I can go 2 and 9. And I can go 2 and 5. So then split that again into 3 and 3. So putting these together will be, I'll go 2 times 2 for this 2 and this 2, 3 times 3 for this 3 and this 3, times 5. That'll be a prime factorization. Notice in each one I've got a pair or 2 pairs. That's going to show later, and I'm going to show you why. So what we have here is kind of the whole number sets. So let's start off on the inside and kind of work our way out. So the really, really easy numbers that you guys know are going to be the natural numbers. So natural numbers are like 1. Natural numbers are right there. Natural numbers like 1, 2, 3. They're counting numbers. So they're going to go right here. So that's a natural. Whole numbers basically are natural numbers plus 0. So whole goes right here. Integers include negative numbers, so they're going to go right here. Rational numbers, rational just means, rational is all of your numbers that could possibly either end or repeat. So it's going to be all integers, all whole numbers, both positive and negative. But then any fraction that's going to either repeat or end is a rational number. All right, irrational number is going to be kind of right here. This is going to be all of your, fractions or decimals that never end or never repeat. Okay? So real numbers is this big circle right here. Real numbers kind of encompasses all of these. Then imaginary numbers, imaginary you'll see a lot in Algebra 2, but that's where imaginary goes. So and then complex kind of bridges the gap between these two. So complex numbers have got a real part, and they also have an imaginary part. So complex is kind of combining those two. All right, so a radical expression is any expression with a radical term. That's this thing. Simplified form, no perfect squares under the radical, no fractions under the radical. That's not radial, it's radical. No radicals in the denominator. That's a big one. So how do we do this? Use prime factorization, write an expanded form, pull out any pairs. So if I look, square root of 50, let's be clever here. So do some prime factorization. So 50 I can split into 10 and 5, but that's not prime yet. So I can go 2 and 5 for 10. So now prime factorization is 2 times 5 times 5. So now this is like saying square root of 2 times square root of, and if I multiply those together, it's square root of 25. Well, the square root of 25 is just 5. Just regular good old 5. So that's going to be my answer. But notice something here, guys. Basically, I'm taking a pair, and when I pull it outside, I just have 1. So if I have a pair underneath, I pull it out and only one of them comes to the outside. So if I look at 48, and split that one, There's a whole bunch of different ways you can do this one. I'll just go 3 and 16. Well, then square root of 3, and then 16 can be split into 4 and 4. 4 times 4. So I've got 3 times 4 times 4. So there's my pair. I pull that out. There is my simplified answer. Notice, when it says simplify, I do not have any decimals. So make that note somewhere. Simplify means no decimals. So I know what half of you guys are going to do. Half of you guys are going to do is just plug it in a calculator, then try to give me a decimal, and then get all mad at me when you get the answer wrong on a quiz or your assignment. Okay, so last one, square root of 32. So square root of 32, I will split into 2 and 16. And then 16, like I did before, splits into 4 and 4. So I've got pairs of 4s. So I'm going to pull that out. So that's going to be 4 square root of 2. All right, so that'll be my answer there. So simplifying here. Here with the variable, things get a little bit different. But if I write out what that means x times x times x times x. That's what x to the fourth means. Notice I've got one pair here, one pair here. That means when I bring it out, I'm going to have an x for this pair times another x for this pair. And underneath the square root is nothing. So there's nothing left underneath the square root. So when I put that together, it's going to be x squared. Okay, another way to think about this is, no, never mind. I won't talk about that yet. Well, you guys are just getting used to this. We'll talk about that later. For number 8, take this and break it apart. So take this in the square root of 4 and the square root of b cubed. Take those things separately. So 4 breaks into 2 and 2. So that's a pair. So I pull out 2. Okay, b to the third breaks apart into b times b times b. So I've got a pair there, so one of them comes out. So I've got 2b, then I've got 1 left underneath the square root. So my answer will be 2b square root of b. That'll be my answer for that one. All right. For here, break this into 3 different smaller problems. Okay, so break this into 3 different smaller problems. So break up 75. That'll be 25 and 3. So that's a 5. So split that into 5 and 5. So here you get 5, 5, and 3. Let's change colors. Let's change colors so we keep it separate from this problem. So you get 5, 5, and 3. So there's a pair, so pull that out. So you get 5 square root of 3. So that's just the numbers. So now the x squared, well, that splits into x and x. And give yourself some room to work over here. The x squared becomes x over x. So that's a pair. So that means x comes outside the square root. So now the y's, that becomes y times y times y. Then I've got a pair. So I'm going to pull out that, but then I've still got a square root underneath. So now to finish this up, I put everything back together again. So I've got 5 square root of 3, x, y square root of y. All I do, it's very simple, keep what's on the outside together, so the 5, the x, and the y, times what's on the inside together. There's my simplified answer. So simplifying using radical expressions using perfect squares. So perfect squares are exactly what they sound like, the numbers that you can take the square root of and get a whole number. So determine the largest perfect square that divides, use product property, take the square root of the perfect square to simplify. You cannot use this with variables, this is only numbers. So I'm hoping you guys know the ones from 1 to 15 without having to think about it, or at least 1 to 10 without having to think about it. 36, 49, these are 5th grade math facts, or 4th grade math facts. 11 squared is 121, 12 squared 144, 13 squared 169, 14 squared 196. This one's easy. All that happens is the 6 and the 9 switch places. 15 squared is going to be 225. You're just going to have to remember that. 16 squared is going to be 256. 17 squared is going to be 289. 18 squared is going to be 324. 19 squared is going to be 361. 20 squared is going to be 400. I expect you guys to at least know 1 to 15 off the top of your heads. That should be what you're recognizing. All right, so if you go square root of 24, let's look at a problem like this again. Okay, one that jumps out to me is that with a perfect square is going to be 4 and 6. Square root of 4, square root of 6. Square root of 4 is going to be just 2. Okay, that's a perfect square. 6 is going to be my answer. Now, what a lot of kids do is they end up trying to go, well, square root of 2 and square root of 12, I can't simplify that anymore. Well, yes, you can, because 12 can be split into 4 and 3. So 12 can be split into 4 and 3. Square root of 4 is now 2, but then you've got this square root of 3 and this square root of 2. Those go back together underneath, and you get 2 square root of 6. So you get the same thing. All right? So when you look at 98, look for the biggest number that can divide that. Well, if you notice from before, if you remember way back on your notes, this can be split up into 49 and 2. 49 is a perfect square, so that's just going to be 7 square root of 2. So 3 square root of 18. For right now, just bring the 3 along. You can't really see that very well. Let's switch it up. Let's go brown. Brown's fun. So 3 square root of 18. 18 can split into 9 and 2. Square root of 9 is just going to be 3. So that's going to be 3 from this one times 3 from here times square root of 2. There's my answer. All right, for 5 square root of 12, again, 5 just comes along. Split 12 into square root of 4 times square root of 3. 5 times square root of 4 is really 2 in disguise. So my answer will be 10 square root of 3. Okay, a tsunami is a destructive, fast-moving ocean wave that's caused by an undersea earthquake, landslide, or volcano. Scientists can predict arrival times based on the depth. So you have this, S equals GD. So if you want to look at that, S is equal to GD, where D is the depth and G is 9.8 meters per second. So if I look at some of these, let's take a look here. So find the speed of a tsunami in a region that is 1,000 meters deep. Write your solution in simplest form. Now notice it doesn't say give me a decimal. It wants simplest form. So 1,000. So basically, what you want to do is take square root of 9.8 times 1,000. So 9.8 times 1,000 is going to be just 9,800. And basically, you have to simplify that. So what I would do is this. Start thinking about the easy ones. The easy break would be square root of 98 and square root of 100. Okay, so square root of 100, I don't know, anytime I see 2 zeros, I want to do that. 98, if you remember from before, can be split into 49 and 2. Sorry, that's a 4. Handwriting's getting a little questionable at this point. So square root of 49 is going to be 7. Square root of 100 is going to be 10. So then I multiply those two because they're both outside, so that answer is going to be 70 square root of 2. All right, now let's go back and look at the problem. That's for A. B says what happens when it's 4,000 meters deep. So that means I need to look at what can happen when it's 4,000 meters deep. So for B, I want to take 9.8 times 4,000. 9.8 times 4,000. This is going to be square root of 39,200. So again, when I split this, I want to go 392 and 100. Okay, so 392, now I got to start playing around a little bit, seeing what can divide that. So 392, and you can try some perfect squares and see what works. So 392 can be split into the square root of 196 and the square root of 2. So square root of 196 is 14. And the only reason I knew that is because I played around with 392. I went into the calculator, started dividing by perfect squares. 196 worked. Square root of 196 is 14. Square root of 2, I can't do anything with that. Square root of 100 is 10. So putting together what's on the outside, that's 140 square root of 2. All right, so A was 70 square root of 2, B was 140 square root of 2. So now the question is for part C, is the speed of water in a tsunami 4,000 meters deep 4 times the speed of the tsunami 1,000 meters deep? Why or why not? Well, looking at the answer, my answers say 70 and 140. So I'm going to say no for part C. No, it's going to be double, not 4 times. So that's kind of what I get when I do that. Okay, that's all I got for this section. Come talk to me with questions. Do not put decimals for an answer, and we'll talk to you soon.